welcome back to Hansolar Engineering. So today I had a look at a bunch of units that had inverter-driven motors in them. I think they were like heat pumps, and there were a few inverter-driven Aircons as well, right? And one of the problems with inverter-driven is it normally has an RMI filter with a Y-capacitor, right? The Y-capacitor would normally end up tripping earth leakages and stuff, especially if you're putting more than 2 or 3 units on. I've noticed, especially with the Aircons, like obviously it would be dependent from the scale of amps being pulled and the type of RMI filter that they have, but obviously then you would end up with an average of like 5 to 10 milliamps per one of these devices, what I found. So what I did was, the requirement, they wanted them on earth leakage. Now I don't blame them, earth leakage is king. But how I solved it is I split it onto multiple earth leakages. Earth leakage can handle, residential earth leakage is 30 milliamps. So if that thing's leaking 10, natural system leakage is maybe 2 milliamps, because obviously if you've got wiring or a motor as is, whatever the case may be, the motor is in a steel housing, and in between its windings to the steel housing there is capacitance, there will be leakage. Do you understand? It's obviously very small, and the leakage from the RMI Y capacitors are a lot higher, like they're 5 milliamps. You might find like way less than that leaking from your motor due to natural capacitance. But still, that's why you put inverter Aircons and inverter heat pumps and stuff, you put them all on their own earth leakage, because at the end of the day, if you run them simultaneously and they're all running at 10 milliamps and your system has natural leakage because of its capacitance, then just think to yourself, you're going to end up with a tripping problem. So you maintain safety, but you're going to have to put in a lot more earth leakages.